Okay, this is quiz 1, problem number 4 on the purple form. So I want to find, is the following function continuous on its domain? So I've got a piecewise defined function, so it might not be. If it was just closed form, no piecewise definition, I know, well yeah, it would be continuous on its domain. Here I have to check. But I only have to check at the endpoints of where this is defined. So I know x squared minus 4, that as a function itself is continuous. But I have to check 0 because at 0 it might be something else. So what I'm going to do, I'm going to check the limits. So the limit as x approaches 0 from the right, the limit as x approaches 0 from the left. Well, okay, I've got f of x here. I want to find the limits of this. So I want to find where I am when I'm just to the left of x equals 0. If I'm just to the left of x equals 0, I'm at -1, -0.1, -0.001. Well, those fall under this category, everything that's not 0. So if I'm to the left of 0, I'm up here. Oops, I said left, so I'm going to do this one first. So I'm to the left of 0, I'm up here. Well, that means I'm going to be using this guy. Alright, the limit as this guy approaches 0. Well, the limit of that, as I approach 0, well, it's just going to approach this. Right? So this is closed form. The limit as this approaches 0, it's continuous, it'll just be whatever I plug in, -4. But remember, this function is not defined as this at that point, so this might not actually be my value. Again, on the right of 0, well, I'm still up here because this is anything that's not 0, so 1, 0.1, 0.001, all of those fall under here. So I'm going to check here when I'm on the right of 0 as well. And again, I'm going to get -4. So this tells me limit from the left and limit from the right are the same. So the limit as x approaches 0 from both sides is -4. So the limit exists, so it might still be continuous. But recall that definition of continuity had two parts. The limit has to exist, and also it has to be equal to the function at that point. So I need to check, is this equal to whatever f of 0 is? Well, f of 0 up here is defined. I've got x equals 0, so I've got this function. Well, it's just going to be 0. Okay. Well, is -4 equal to 0? I'm hoping you're saying no. So that means that the function at 0 is not equal to the limit as x approaches 0. It's discontinuous at 0. So it is not continuous on its domain, because there's a point of discontinuity. If there's any confusion as to whether or not 0 is in the domain, let's look here. If x is not 0, certainly it's defined. I've got this is continuous, and this is defined everywhere that's not 0. Okay, so I've got everything that's not 0 in my domain. But if x is 0, well, I've got this, so 0 is in my domain, because I can plug in 0, I'll get a number, I'll get 0 back out. So 0 is certainly in my domain. So 0 is in the domain, but it's not continuous at 0. Well, it can't be continuous on its domain.